In this video, we will be learning about the many different pathways to moles. This is part of our learning objective for applying stoichiometry relationships to calculate the amounts of substances involved in chemical reactions. In the past video, we talked about how you can use the stoichiometric coefficients in the balanced chemical equation to develop a molar ratio, also known as a stoichiometric factor, in order to convert between moles of one substance in a chemical equation to moles of a different substance in a chemical equation. And that's the main new concept for this module. In previous modules, we've talked about how to convert between mass of one substance into moles. We've also talked about using Avogadro's number to go from counts of objects into moles. And we've talked about molarity for going from a volume of a solution containing a substance into moles of that substance. So we have seen molar mass, Avogadro's number, and molarity used as conversion factors to get to moles in previous modules. We've also talked about mass percent composition for a substance like a compound, and also density for a compound as conversion factors. So we've talked about many different conversion factors in order to get to moles. And so we have to decide what are we going to do to get into moles so that we can use this molar ratio to get into moles of the substance we're looking for. And then after we're in moles of this other substance, then we might need to get out of moles in the same way. So now we're going to be wrapping our molar ratio with additional conversion factors to help us get into moles and get out of moles. So we have to remember that stoichiometry is as easy as 1, 2, 3. 1 being get into moles, 2 getting into moles of the substance we're actually interested in, and then 3 getting out of moles into the unit that we're searching for. So here's a practice problem. In this problem, we're not actually asked to set up the math at this time. We're just asked to come up with a solution map. In other words, try to identify what conversion factor you would use for each step. So you have to identify how will you get into moles, how will you change substances, and then how will you get out of moles. Go ahead and pause the video and try to identify what conversion factors you would need in order to do this. Unpause the video when you're ready to continue. Alright, so it says what mass of FePO4 that's what it's asking for. So we're looking for mass in grams of FePO4. And we are given, that's what we're asked to find, we are given volume of the solution. And so we are given 35 milliliters of 1.25 molar Fe2SO4. So that's iron 3 sulfate. So now let's see. So we're starting with milliliters. Anytime we see this in a chemical equation, specifically the molarity part, molarity is a conversion factor. Because molarity stands for moles per liter. And so we're going to have to go from milliliters to liters so that we can get into moles using molarity. We're going to be using the molarity of 1.25 moles of Fe2SO43. And then how will we change substances? Well, whenever we're trying to go from moles of one substance into moles of another substance, that's when we're going to use our molar ratio. And so to do that, we are going to use our mole ratio, which is 1 mole. Remember, 1 coefficients are not written. And then that's going to be the 2 moles of the iron phosphate, iron 3 phosphate. Okay, and now that we're in moles of iron phosphate and we're asked to find grams of iron phosphate, we're at least in the right compound. So in order to go from moles into mass, then we're going to need to use the molar mass of iron 3 phosphate. So we would need to calculate this. That does not look like the word calculate. That looks better. Alright, so we would need to calculate that, but that's not part of this problem. It says how will we get into moles? We're going to use the molarity to go from our volume to moles. So our first conversion factor is going to be molarity. We will change substances by using the molar ratio from the balanced chemical equation, and then we will get out of moles by using the molar mass. So now we've come up with our conversion factors for this problem.